So let's do the inverse cosecant of square root of 2. Now, just a quick reminder before we start this. Tell me about reciprocals and inverses. Are they the same thing? No, a reciprocal and an inverse are two different things in trig. Reciprocals and inverses are not the same thing. So when I ask you to find the inverse cosecant of the square root of 2, what am I really asking you to do? The inverse sine of 1 over square root of 2. Or a better way of writing that, because you have it memorized this way instead, is root 2 over 2. Now look how easy that problem is. You just flip it over and do sine or cosine instead. So what's the answer? Which is pi fourths. Okay. Let's do secant, arcsecant of negative 2. Instead of memorizing the chart for secant and cosecant, just go ahead and do reciprocals. So what's the other, how do I turn that around? It would be the arc cosine of negative 1/2. Now when cosine is negative, it's in quadrant 2. So what angle, reference angle, but in quadrant 2, so you have to use the reference angle to find the angle in quadrant 2, is cosine 1/2. Cosine's 1/2 for 60 degrees, correct? Which is pi thirds. But we want it in second quadrant. 2 pi thirds. I hope you were all really comfortable with that chart, because now we're beating the heck out of it. So if you weren't, yeah. Okay, here are the ones that totally will freak you out. Here we go. Arc cotangent of negative square root of 3 over 3. Now, how have we been doing these other problems? We've just been changing them to sine or cosine. So can we do that? Can we do arctangent? We can if we're really careful. Okay, so go ahead and do arctangent and flip this over. What would it be flipped over? Negative square root of 3. So if it were tangent, it would be quadrant 4 because it's negative. But since it's cotangent, it's quadrant 2. So it's a positive quadrant 2 angle. So kind of ignore the negative for a minute for me and just go with the reference angle. What reference angle is tangent square root of 3? I can never remember these. It is 60, right? Okay, so if we were actually doing the arctangent of a negative, then the answer would be negative 60 or negative pi thirds. But we're not actually doing that. We're just using this to figure it out. Be careful. So we actually have to do quadrant 2. So instead of doing a negative pi thirds, the answer would be 2 pi thirds because cotangent is quadrant 2, not 4. You hate cotangents now, don't you? Okay, it gets worse. Let's try doing these with a calculator. Okay, so those were all exact ones, right? So these were all exact. Our last little group of practice problems are approximate. Okay, we want to find the approximate value in degrees for secant -1, 6. Okay. Is there a secant button in your calculator? No. So what do you have to do? 1 over cosine. That's going to keep messing you up unless you get that like that. Okay. So go ahead and do... Oh, yeah. It is the inverse of cosine. And the reciprocal. It's the inverse and the reciprocal all in one problem. If you want, you can do them separately, like find the answer and then do 1 over that. Wait. Am I doing something wrong?
Yes, you are. You're doing it wrong. You're getting an error. You have to do the same thing you do for the other ones.
I'm doing exactly what I'm trying to teach you not to do.
It's cosine inverse over 1 over 6.
Cosine inverse of 1 over 6.
That's what you're supposed to do.
That's it. See how hard this is? I can't even remember how to do it.
I was looking at it, I was like, doing the same thing
I
over
did
and
that
over.
on purpose so that you would see the common mistake and not make it. Okay, so now you go for it. It's easier. What do you get? What'd you get? What'd you get? 80.4 degrees. Is it possible, we've been doing all of these in degrees, but is it possible they would ask for these in radians?
Yes.
Yeah, so. Anyway, okay, we can't be done yet. Okay, quickly, let's do a cosecant. So that would be the sine of 1 over 4. We'll get to that one in a minute. So what'd you get? 14.5 degrees. Okay, now let's do the arc cotangent of 2.4. Look, it's positive. Guess what? It's all quadrant 1 when it's positive. Yeah. Okay, so we just have to do inverse tangent of 1 over 2.4. And we're good because it's all quadrant 1. Positive is always quadrant 1, which is wonderful. What'd you get? What is it? 22.6. Okay, what about, I want to try, I don't know. Should we do a -1? Yeah, we should. So let's do cotangent of, let's do a negative, I don't know, give me a number. I don't have anything written down. Okay, sure. Okay, do we have any choice but to use the tangent? We really have no choice but to use the tangent of -1/4. But stick with me on this one because we're going to have another step once you've plugged it in your calculator. What did you get? -14. What's the decimal? Point what? 0.03. Okay, so we'll just call it. Okay, good. Okay, but that one is quadrant 4. So we have to change it to quadrant 2. And that's a 14-degree reference angle. So when you're doing a reference angle in quadrant 2, what do? You go 180, subtract 14. Yeah. These are gonna hurt your brains a little.
So if it's cotangent, all you have to do is make it in quadrant 2.
Yeah.
And that's the rule?
Yeah.
That's the law.
Yeah.
Why did you have to put in quadrant 2?
Because cotangent only exists in quadrant 1 and quadrant 2. Not in quadrant 4. But your calculator doesn't do that for you. You have to do it.
This is more fun than watching.
There's kind of some other examples. You're probably going to hit some problems you don't know how to do. Try them.
They use a solution to go backwards.
Okay, use the solution manual to go backwards. Try them. Try working through them on your own first. I can kind of show you one if you want, but I think we're kind of done. Here, let me kind of show you the idea. Some of the problems combine stuff together, like you might do the arc sine of the cosine of pi 6. What does this mean?
Find the cosine of that thing and then you do the arc sine.
You work inside first. So you would do the arc sine of whatever that answer is. So what's the cosine of pi 6? Square root of 3 over 2. Then you do the inverse sine of square root of 3 over 2, which is pi thirds. Does that make sense?
Yeah.
And sometimes they'll be the other direction. Like you might have to do the inverse sine. Oh wait, not the inverse sine. Let's do something totally different. Let's do the tangent of the inverse sine of square root of negative square root of 2 over 2. Oh, that sounds fun. So what's the inverse sine of negative square root of 2 over 2? Negative 45 degrees. So then what's the tangent of negative 45 degrees? Isn't it just negative 1?
Don't worry, you only have to do 10 of those problems. 10 of those problems and then 26 of the rest.
Okay, you got the idea. Okay. Make a song for your quadrants. Oh, you forgot to make a song for the chart.